All right, lesson 9.3, we're going to be solving some quadratic equations using square roots. So we'll solve the quadratic equations using square roots, and we've been working a lot with simplifying radicals and square roots. Then we'll approximate some solutions. We've also had a little bit of help with that, or experience with that too, rounding to hundredths, tenths, whatever place we want to round to. So earlier in this chapter, mainly in 9.1, we studied a lot of the properties of square roots. So we're going to use square roots to solve our equations, right? Like this. First, we're going to isolate x squared to one side to obtain this like x squared is equal to d. Very abstract right here, but looking at that, then we're just going to solve using the square root of both sides. So we want to isolate x squared. All right, so the solutions, x squared equals d, when d is greater than 0, x squared equals d has two real solutions. We'll have a positive and a negative. When it is equal to 0, we have one solution, and it is 0. When it's less than 0, we have no solutions. So we'll be examining that. When we solve quadratics using square roots, we can follow, this is the example out of the book, so we can add 27 to both sides. Then we would divide both sides by 3. We get x squared is equal to 9, and we can find that x is equal to plus or minus the square root of 9, which is plus or minus 3. So we have, as solutions to this, x would be equal to 3, or x is equal to negative 3. Now, look what this is saying right here. Another way is by factoring. So pretty much chapter 7, finding zeros, finding roots, things like that. We've used this terminology before. We've seen binomials, trinomials, all things equal to 0. We've made equations equal to 0, and we've used factoring. So if we factor out a factor of 3, then we have a difference of 2 squares that simplifies to x minus 3, x plus 3. Then that's how we solved it. We'd say, well, either x minus 3 equals 0 or x plus 3 equals 0. So we get x is 3 or x is negative 3. This is the place on the graph where it crosses the x axis. So it's all connected. So we need to remember that. All right. So this is not a difference of 2 squares. X squared plus 49 is actually not factorable. That might lead into an idea about what the solution might be, but let's just solve it. We will subtract 49 from both sides. We get an equation, x squared is equal to negative 49. To get x, we need to take the square root of both sides. We cannot take the square root of a negative number. Therefore, there are no real solutions. And that probably explains why we can't factor it. All right. Looking at number 2, we want to isolate x squared. All right, so in this case, we have x squared is equal to 25. You probably know easily what this is. We have x is equal to plus or minus 5. X is equal to 5, or x is equal to negative 5. I will note another thing we could have done here is taken it as, x plus 5, x minus 5 is equal to 0 because it's a difference of 2 squares. So anytime you can see a difference of 2 squares, you could do that. Here we want to subtract 6 from both sides. X is equal to 0. Oops, but that's an x squared. All right, so when we take the square root, believe it or not, the square root of 0 is 0. So in this case, we have one solution, and it is 0. Here we had 2. Okay. Number 4. Number 4, we want to subtract 84 from both sides. So we'll get 2x squared is equal to negative 84 and divide by 2 to get x squared is equal to a negative 42, and then we'll know that to try to take the square root of both sides, we can't. No real solutions. You can, at this point, we're not ready to use imaginary numbers. So we can't use any real numbers to solve this because you cannot take the square root of a negative number. There is no number times itself that would equal a negative product. For this one, add 72 to both sides. So 2x squared is equal to 72. Divide by 2. x squared is equal to 36, you can take the square root of 36, and you can get x is equal to plus or minus 6. Okay. I have to move this out of the way. All right, give us another angle here. So we'll add 12 to both sides. So we have negative x squared is equal to 0. Then we have to divide by negative 1. So x squared is equal to 0. Therefore, x is equal to 0. One real solution. All right? Pretty much concludes lesson 1.2. Well, actually, it doesn't. Don't you just love that? All right. So what we're going to do now is kind of approximate our solutions, possibly to the hundredths place. So we'll get all the way down to the end. We'll say plus or minus. And in this case, mainly it's because we don't have perfect squares. We've got pretty far so far this way with perfect squares. So you're still isolating x squared, still getting, so when we have plus or minus the square root of 7, even though it's an irrational number, it's still a real solution. It's still a real number. Therefore, we can approximate it. So that's what we're going to be doing. So far. But yeah, so close, but so far. All right, so we'll subtract 6 from both sides. So x squared is equal to 2. So we get x is equal to the square root of 2. And then I'm going to do this on my calculator. The square root of 2. So I'll get, now remember, because this is the square root, it could be the positive or the negative. So x is equal to plus or minus 1 point, and it said 1 because it said the hundredths place. All right, so keeping 2 places. Right, not the tenths. All right, adding 12. I bet you're finding this to be very easy. All right, so x would be equal to the square root of 15. And again, square root of 15 would give us approximately, I should probably be doing little squiggly lines, right? Little squiggly lines because we're approximating. 3.87 plus or minus, and there's 2 real solutions here. Let me go quick. I think, well, all right, I'll let you do number 21, okay? And then we'll do the final problem, which is going to be a word problem. So we're dropping a ball from a window at a height of 81 feet. Here's the function, okay? So this represents the height of the ball after x seconds. How long does it take for the ball to hit the ground? Basically, we want to solve for x. So on this one, let's do it. Look at these 2 perfect squares. Let's do this. We got to factor out a -1. So let's do that. So 0, right? When it hits the ground, it'll be at 0. If I factor out a -1, I get 16x squared minus 81. So that I have a difference of 2 squares. I have 4x plus 9 and 4x minus 9. Remember one of these. Now, I could have just simply added 81 to both sides, blah, 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 divide by -16, solve for the x. But why not do it this way, just for fun, to show you the relationship and how it all connects to everything we've been doing since chapter 7. So either 4x plus 9 equals 0 or 4x minus 9 equals 0. So we would subtract 9. 4x equals -9. So x is approximately, when we do this, 9 divided by 4 is approximately 2.25. Doesn't really say what to round it to, so let's do. Does that make sense? No, it does not. There's our extraneous answer. So this is the one we really want. And x is approximately 2.3 seconds in positive values for time. And that's how we would find about how long it takes before it hits the ground. All right, now we're done.